because we have virtual students and in person, I'm not going to write too much on the whiteboard. I'm going to write on the slides so that you can still, see very clearly, and virtual students will be able to see it. Occasionally, I may write something just, off the record so that we can hide it from the virtual students. All right. So I'm going to ask a few questions in a few seconds after 15 minutes, just so that nobody will miss it in person. I promised the bonus questions. I'll ask them 30 minutes into the class so that nobody will miss it. So be prepared. If you want to prepare for it by reviewing the slides last week, you can do that right now. Anyway, so if you recall, if you have read the books, the first 3 stages of the process of data mining project: understand the problem, understand the research question, understand the business problem. Right, those are background understanding, and that's a must, of course. And then you come to a stage where you understand the data as well as to prepare or clean or pre-process the data. And from the industry-wide projects, especially in business, reports have said that these stages, especially the data preparation or data pre-processing stage, usually take about 80% of the project time, including maybe collecting data, because especially in business, these data sets are usually, most of the time they are collected and they are stored not for the purpose of data analytics, but for the purpose of operations, running the business, or other purposes, or just record keeping, so that you have data on books. You have to transfer data on books to computer. That alone is a challenge for many, especially small firms. So all those consider different challenges. But I think as a society transform, as well as the business domains and business organizations, they have been transforming from physical record keeping to digital record keeping. I think this effort has been shrinking. So I think my estimate now is probably at 50% of all the projects in business in terms of data mining or AI. Of course, some companies are more ready, like Tesla and Amazon. Their data already in the database and ready for crunching. Just depending on the problem, the scale of pulling data from different places and cleaning them, identifying problems, and also fixing them before you get to the stage where you develop models, varies, depending on nature of the project. But I think time spent on simply collecting data has been shrinked significantly, just because of digitization trend that's happening everywhere. So my estimate is 50%, but don't take my word for it. It's just my sense. So, and still, if it's 50%, still a significant amount of time. If a project takes 3 months, you're spending 1.5 months dealing with different kinds of problems with data. The reason is quite obvious. There are so many challenges, and I'm not going to talk too much about data set from legacy systems, that have to be migrated to modern systems, and data are corrupted, all kinds of data issues and securities. I'm not going to talk too much about that, but just realistically, even if all the data are accessible and not corrupted and in the database, you still have a lot of other issues to deal with for every project. So I'm going to talk about a few, I guess, mindsets or frameworks that you do, which applies to almost every project, tricks that you use to detect problems and fix problems with data, common types of problems. So missing values, of course, is one problem. Missing values happen in one kind of data where you collect data from humans. You have to collect through surveys or user input from self-disclosure, things like income or age or gender or address. Quite a few of these information are private, and it's understandable that some people do not want to disclose, and it's understandable. So that creates a missing value problem. For machine learning, it's bad because, but still it's inevitable at the same time. It's bad because machine learning, the principle of machine learning is to try to discover patterns from data. If you don't have data, what else can you do, right? But the good thing is, with the power of computers, you're not relying on one or a few columns of information. You're relying on everything that you have. So missing values present challenge, but you can focus on the other efforts to try to circumvent the problem. Despite the missing value issue, you might be able to do something else to enrich other aspects of data. For instance, with most devices right now, they can keep track of all the activities. Sometimes, even if you don't know the age of a YouTube viewer, you know what he or she watched in the previous month. The whole trace of records. That's probably much more useful than knowing the age. Age variable affects the viewership behavior in a very vague way. You cannot extrapolate too much. But every viewer's preference and tastes is different, as well as it will evolve over time. The best information you can have about or the best information that's going to be helpful for you to predict what videos the viewer will watch in the next phase is what has been watched. That's probably the best predictor. Mason, question? No. Okay. So missing values is a problem in terms of the task. Also, in dealing with missing values, when you have a huge data set, let's say you have 1,000 columns, and missing data can appear anywhere here. And examining the columns one by one is perhaps laborsome, is challenging as well, but you have to have some kind of process to deal with. We are not going to focus on missing values here because it's technically a lot to handle. It requires quite a bit of Python foundation to do that. Otherwise, you find yourself dealing with the bugs all the time. You have this bug and that bug, try to fix that, and you're exhausted. So that's why we're not going to deal with that. All the data sets that are available in this course for homeworks and projects, they are either void of any missing values or have very light missing values, which I will give you the script to run in order to fix it, right? So missing value is not a focus here, but we will, at least for some of the questions, you'll practice how to do some other tasks in terms of data preprocessing, including some of these I can't find my pen. Oh, it's here. Sorry. Laser. Okay. So I guess I should say I'll teach you how to, or the best way to quickly identify problems with columns and column features, attributes, the same thing. Problems with the data set in terms of the variable names. Especially in Python, spaces are not a good thing when you process data as well as the labels. So you want to avoid spaces as much as possible. And if you you didn't create the data set, you're handed with a data set. The data set has column names that include a lot of spaces, and then you need to be prepared to fix those. This is somewhat related to naming conventions in programming. In Python, we basically have two kinds. One is using underscore. We don't use minus that much because minus is sometimes confused with the minus operation, subtraction. So underscore is the best way to replace the spaces in naming. Let's say, education level, education underscore level. That's one way. All of these under lowercase. Another way is to use camel style. Camel, like initial first letter capitalized, and then you have long string where you have capitalized letters in the between, in the middle to indicate a new word. So that looks like camels, right? Either way is fine. And so that's one thing you would pay attention to when you're try to understand a new data set. Are the column labels in a good shape? Do you need to do something about it? And besides the labels of the variables, you also it's inevitable you will deal with categorical variables. It's kind of the background. What is a categorical variable? It's a variable that has a limited number of possible values. It can be numeric as well. So categorical variable doesn't always have to be a variable with text. It can also have numeric values that only possibly take a few values. So a classic example is when we talk about cars. A data set with different car or vehicle models and versions. One variable, which is numeric as well as categorical, is the engine size. For cars, you only have a limited number of engine sizes, right? You have 2 liter, 3.6 liter, and something like that. So you only have a few, as well as number of cylinders. So these are categorical variables. But textual categorical variables include gender, if male and female, or maybe possible other categories. So it's inevitable that you will need to transform them because computers cannot process text data very well, or it's not ready for being included in the model. Data type problems. This is an interesting case that you will very typically encounter, I think. So a date column that takes basically any values, but when users input the date, they know they have to input numbers and use this kind of a format, year, month, day. But I guess the database doesn't restrict too much on the way that you can input the numbers. So for this, it leaves some room for doubt, 7 digits instead of 8, which, kind of becomes vague. But based on this value, you can kind of be pretty sure what the date is. 2019, January 31st. It's not going to be 2019. I don't even know how to say that month. 13th month? The first day of 13th month. It's not going to be possible. We understand. Computers don't. So, but as long as this value can exist, something else could exist, right? You could have something like that. So now, it leaves room for doubt. Is it 2020 November 3rd? Or is it 2020 January 13th? There's ambiguity there. And it could very well happen if, the data entry, ignoring or omitting the 0 becomes a habit of data entry, creates a problem. And certainly it will create a kind of a disaster scenario for machine learning algorithms, because the two dates are very different from each other. It's almost different by 10 months. And it's going to lead to sort of misinformation. And misinformation for data mining algorithms is a disaster. You cannot trust the information. How can you trust the algorithm, right? I think that's all the examples I want to talk about. Let's see. Oh, in terms of collecting data. So nowadays, one of the biggest challenges of trying to apply machine learning algorithms, like all those fancy and powerful neural network models, the challenge to applying those is not computers. We have powerful computers. Laptops even can do a very good job. Some laptops, gaming laptops, have GPUs. They are powerful. They can do a lot. So it's not about equipment. It's not about software packages. We have open source. The models can be implemented in multiple languages or multiple platforms. It's mostly of high quality labeled data set for supervised learning, let's say. Because the thing is, for supervised learning models, the model can only do what you train it for with the good quality data. And that's why this is one of the frontier areas for research. Top researchers in I guess neural network models or computational neurology. So those areas, they are trying to figure out how to design the model. It has to be on the model design level. How to design these models so that after being trained, the model can extend their skills onto areas that are not trained for, at least not strictly, right? So if you train a neural network that can, I guess, if you train a neural network that can that can tell the object in the picture, can you reasonably expect the model can also tell you how close the same objects, but of different colors or maybe different size, not only size, but I guess colors, hair color, or different slight differences in some of the common features, how close they are. So these are not exactly the same task, but they probably rely on the same fundamental skills for the computer. For the algorithm to be able to tell which object, or let's say an animal, or a human, or something else, a desk, the algorithm has to understand the key features visually, the visual key features of these objects, and use those to help differentiate the objects. So if the model knows how to associate unique features with the object, or the category of the object, without training the model specifically on similarity or closeness, can you expect it to do reasonably well on that? That would be a scenario where, I don't know what you call it. It's like breaking the restrictions of machine learning models can only do specific tasks that are trained for. So things like that. The frontier research areas are doing that. We're certainly not in that stage. So for this class, the model that you trained can only specifically do the task that you train it for. So because of that, imagine that you want to apply, or you want to use machine learning capability to solve your business problems. You can think of 1,000 business problems very easily, and you need 1,000 models. For each of those models, you need a good-sized, high-quality data set. The scale of the need for a data set, as well as for custom training, is just unimaginable. You just cannot do that one by one. So that's why I think things like neural networks, deep learning, machine learning has been popular for a while. It's still, the use of it is still limited. The barrier here is still, with the lack of ability to transfer the capability of the model without having to train it with high quality data sets specifically for the task. Collecting data, or if a company doesn't have talent to train neural network data model, how can you expect them to know how to collect high quality data set to start the training process? It's not realistic expectation. So that's why the speed is kind of limited to extend the applications. But in terms of collecting data, there are some modern ways to do that. And one of the examples, I'll talk about age in a second, but so in terms of collecting, or we call labeling, data is where, let's say, I use examples of images because it's very visual, it's easy to understand. You want to train a machine to be able to tell apples from pairs. You need to label each picture, which provides the ground truth for the data, for the machine to learn. Otherwise, if you mess around with the ground truth, the computer is not going to learn. Well, you cannot trust it. That's what we call labeled data. For every training example, you have to label in the data set, say this is apple, that is pear. So that's data labeling. Most of these jobs are not difficult. I mean, all these tasks are what humans are good at, and this is in our context. We want computers to learn how to do things as well as humans can do. That's the gist. But you need to teach computers what these are. So labeling data, to label 1 or 2 pictures is easy, but to label maybe 100,000 pictures, it takes some time, and nobody want to do it, I think. But there's some modern solutions. I don't know if you know about, this has been along for 16, 17 years. It's called AMT, or Amazon Mechanical Turk. It's affiliated with Amazon, but not, I guess it's not run by Amazon specifically. They are kind of separate. Mechanical Turk. So this is a platform where you can assign tasks for people to do, and you pay for the tasks. And there are similar platforms as well. But AMT is kind of popular and notorious at the same time because the pay rate is so low. Let's say the popular tasks are, in the early years, it's picture annotation, because in those years, computer vision was catching up, and later, more of a voice annotation. Transcribe sentences in the video, in audio clip into verbal texts. That's transcription. Those tasks will probably pay for maybe $1 an hour at best. So in an hour, you can probably transcribe 40 sentences. And let's say an hour for 40 sentences, it's how much? That might mean $1 for 40 sentences. It's $0.025. It's 2 cents per sentence. That's very minimal payment. But it has 2 merits. One, it attracts a lot of workers, and workers compete with each other in a way that works, to the advantage of the, I guess, those they call requesters, those who hire workers. So it over time it grew more popular. There are some protests, of course, and the case with this is similar to Uber and Uber, Lyft, and ride-hailing, where they argue their employees they should enjoy the benefits, but it's a very emerging and challenging space, you can imagine. But this is where you can collect quite good quality labeled data by paying a low amount of money. So low cost and high efficiency, I guess. There are some best practices. You cannot trust all the workers, of course, because who knows if they are just clicking without looking. Of course, they will be punished, but do you have the time to check everything? If you have the time to check everything, you probably as well do it yourself. right? So that's not a viable solution. But the way to overcome that quality issue, there are some best practices. You can, for each task, you can hire 5. Because the payment is so low, you can afford to have some redundancy here. And you can leverage the redundancy to ensure the quality is good. So how do you do that? For each task, if you hire 5, and you only approve the result if at least 4 of the 5 agree with each other. And that's pretty good, quality assurance. And you put in a little bit more cost to make sure your data quality is good. So that's one way. If this is, I don't work for Amazon, or this is just something that is probably sometimes the only choice companies have if it's if you have low budget to acquire high quality labeled data set. I think with pictures and some people some companies process a lot of receipts, and they have to put receipts into accounting systems, but doing it manually is so laborsome. So they take pictures of the receipt and put it up there and ask them to input the amount, AMT workers, and that's one of the popular tasks. Most popular tasks, at least 3 or 4 years ago when I do the research, is picture tagging, or recognize the object in the picture, or audio transcription, translate or transcribe what is in the audio clip. So that's most popular. Other than academic research surveys, they also post surveys over there to find research subjects. That's another popular outlet for finding research subjects. The kind of thing I do. That's why I understand that quite well. So that's just something for you to know. Okay, and one classic scenario with doing the best practice in terms of preparing data set for data mining is when you deal with people in terms of the research problem. If you're predicting anything that humans will do, then you'll probably deal with the age variable, because age carries quite a lot of things. In terms of spending power, if you know the age is 16, you probably don't expect too much spending power. But if the age is 64, they have money. so you can expect. So that's predictive. That's what we call the attribute is informative or has predictive power. But it's predictive only to some extent. We'll talk about that more later. But so the best practice with recording the age information about your research subjects. Recording age, is it the best practice? What kind of problems can you think of?
Age is going to change over time.
And data remains static. Yeah, it doesn't. Of course, you can put in some scripts. Database has scripts. You can update that using the scripts. But by knowing the age, there are more challenges. When do you update? January 1st? That's going to leave room for some bias. Don't be overconfident with your scripts, right? So the best way is to record the date of birth, because even if, you get this information by asking people. If you were to ask the age, and they have to calculate. Why don't you ask for birthday? They don't even have to calculate. So that's going to be easier. But birthday presents some privacy concerns. So that might be the only reason you would avoid asking for birthday. Then the next best thing is to ask for age. But then you would have to make a decision on how to convert that age into birthday. Maybe convert to month, birth month. and that's even better than age alone. You can always calculate age if you have the birthday information, right? So that's and I think the damage with recording age alone is not particularly with machine learning, because age alone doesn't carry too much predictive power. You know, you better have other behavioral traces. But you know, analytics is not only about training machine learning models, bookkeeping and, you know, customer segmentations and marketing campaigns. You still need reliable information about age. And if age doesn't update itself, it's not a good thing. Great. It's time for some questions. I mean, bonus questions.
We have one question, Professor.
Yeah.
So you're saying earlier when companies create models that is there normally like maintenance associated with updating those models and making it like iterative? I'm thinking like if my company doesn't have a data science or business intelligence department and outsource somebody to make a model, do you think is it common for them to have like follow-up consultations like a year or 2 years or 3 years afterwards to, I don't know, refine the model or keep improving it, or is it just like make the model and done?
That's a great question. I suppose the company will learn based on the first project. They will evaluate, you know, value returned from the implementation. I think if the company or if the team is serious and based on the current trend, over time they're more likely to develop some internal, you know, competencies. And it's not like it's so complicated. It's not rocket science, at least. You know, I can do it. It's not rocket science, but some internal capabilities will carry a long way if the team is committed. I think based on one project, the team can upskill capability quite quickly. And even now, I think they can hire interns to build internal capabilities and move and, you know, transition to a bigger team. But of course, I just don't know how consulting firms can do well in this territory. You know, because a lot of times the company is not ready to start a BI effort, not because of time, but because of readiness. I think data is, you know, the consulting firm cannot hand you data set. It has to come internally, and the system has to be ready to do that. So it's either going to be a very long project where data collection takes the most of the time, or it's just going to fail, or, you know, else. So it's quite different from other consulting services to me.
Thank you.
Yeah, sure. Just my mumbling. I don't know.
No, all good.
Valerie?
Is there a way for machine learning to build like self-adjusting models based on new data sets that come such that different updates by even being by them?
Great question. It's not difficult to do, but there are critical assumptions behind it. So let me talk about the technique that's being used. Let's say Google. Google has to constantly update the model. Yes, and it's not like the company has to do the whole thing with mostly manual or teamwork every 3 months or so. It's not like that. They can build the model pipeline in such a way that the model incorporate new data overnight from today, let's say, and update the model overnight and use it tomorrow. And then tomorrow night, it incorporate new data. It's not like it has to be trained on all the old data. It's going to be taking a long time, but it's not necessary. The model, once it's being trained on a massive data set, the model is, I guess, state of the art. When you have new data, you train it on it, it's not going to change the model dramatically, assuming, this is where the critical assumptions are important. Assuming the problem nature didn't change, the way people behave didn't change too much, but there's always going to be things that are evolving and emerging, and the model can pick that up and slightly shift itself to, I think that makes sense. That's with you learning how to ride a bike. You ride a bike, every time in a familiar setting. Over time, you have this habit, and you don't have to even pay attention, and you can do it. But if you ride a bike in a new neighborhood, you'll pay more attention to the new things that are not familiar. So you change your, you change your habit or change your attention slightly, and then you get used to it again. So I think metaphor is similar. Models can be implemented in a way that it learns things from new data set. This is called online learning. The model can learn, do you have to trigger the model to learn? You can still set up automatic processes. You don't have to, but over time you will check on the model and see. So that's not a problem. It's very commonplace, at least in big tech, like in Facebooks and Google, things like that. Is that good? All right, so let's do some questions.
One follow-up question.
All right.
On that. What if there are extra variables or features that has to be added into older model, or that are introduced with the time? Like there are subset features or subsetting features or something like that.
What's auto model?
For example, I develop a model.
Yeah.
It's running. Well, over time, as the customers use it, there is an extra feature or extra variable that has to be added into that model. Or it happens along the time that there is an extra feature that is required into that model. When and
it's not easy.
You need to update it, or when and what time you need to check that out.
That's an excellent point. I didn't explain the critical assumptions. The assumption is that the problem, the nature of the problem didn't change fundamentally. No new important variables are being introduced in the problem space. That is a critical assumption. So, the first time you develop the model, you want to make sure you consider as much, variables, as many variables as possible. And it's not like every variable will become important, but you need to consider that when you develop the model. And then in the model development process or evaluation process, you probably will simplify the model a little bit and decide which variables are important. So it's important from a project management point of view or a cost, management point of view, to initially consider all the relevant factors, to not allow significant room for new factors to emerge and ignored from the initial development. So that's critical. And that is a reasonable assumption, though, because a lot of times you can do that. And at least for successful applications, new factors don't emerge that quickly. And if that do, probably a lot, I mean, the fundamental environment has changed, so in practice, it's not usually a big concern. Sure. So let's do some questions. I have a list of these, but I don't have time to go through all of these. So we just have to pick. I'll probably do 3. Sounds good. For virtual students, you probably just, have to listen, and I'll repeat the answers, of course. Let's see. So I'll ask the question. I will not ask you to raise your hand. You just scream the answer. The first person screaming the answer correctly will get the reward. Okay? Let's see. The first question. What method is your first choice when you need to ask a question about the course activities? I think Angela said the answer first. Teams, right? Teams, right? That's something I want to emphasize. Always, because I think over time that's the best way. Although it doesn't feel as good as sending me an email directly and I answer the question. So that's the rush. That's the sugar rush. It feels very good. But I have hindsight, and I'm not available 24/7. So still, I think when I compare different solutions of Q&A, the best way is still to have a digital platform that can reach everybody quickly, and also is rich media where you can post pictures, videos, even screenshots and comments and annotate. So far, of course, I didn't explore too much outside what we have, like forums, Blackboard. It's not good. Try it, and other availabilities. But not everyone has smartphone back several years ago, and so that wasn't improved until Teams come. I think Teams work very well. The notebook. So great. Let's see. And where are you? All right. Ready for the next question? Can somebody explain? Don't raise your hand. Just go ahead and say it. Can you explain what classification task is? Can you explain what classification task is in terms of machine learning?
To group similar variables into a group so that they are not similar with the variables in the other group. So kind of club similar variables in one group and non-similar variables in the other group.
Is that Uvi? Or what's your name?
Judy. It's Judy.
Oh,
I am.
your mask. I'm not exactly sure which one is talking about. Sorry. That's close, but not exactly. So let's try it second.
Is that a big data and a small one? Do you consider the small one the Amazon one, like the?
I'm afraid not. I'm afraid not. Say it again.
It's like numerical categorical data.
Can you expand? So classification task. What does it do? Or give an example.
Variable beings. So different categories, like so I have people from group A, B, C. To model them, I'll identify group A as 0, group B as 1, group C as 3, for instance, and leave out group 4 as the base, but the reference for the categorical model.
What did you say after you said you have 3 bins, let's say?
Yeah, so if I have a category of 4 basic features, for instance, the model then code data mining. I will code those 4 variables numerically.
I see what you're saying. I see what you're saying. Not exactly. So let me say, classification task is where you have a target variable. The target variable is a categorical variable, like Valerie explained. Categorical variable is where it only has a few distinct labels, like high or low income, like cat versus, dog. Right, and it's a target, not the input. The target is that, and you're trying to classify, and train an algorithm to be able to tell if this, which case is this, or which case is that. Given a picture, is this a cat or dog? That's classification. In business, you would say, let's say for Google, a random visitor of a random user is using Google to search a term. Google is trying to decide, should we, let's see. Should we display the ads for this keyword or not?
The book, it says the model is named as a large set of records, each record containing info on target variable. And like if the goal is to classify the income bracket of new individuals based on characteristics of those already in the data set.
Right. So trying to predict if this person is rich or poor, basically, right? So that's in the business case. So that's classification.
Classification is used for only structured data or only for unstructured data?
But I'm trying to think. When you say unstructured data, it's typically referred to either pictures or hyper rich media is unstructured data, or text data. Classification can be used for both. So there's a way to structurize the unstructured data, basically. If the unstructured data cannot be encoded in a way that can be numerically represented in the data set, then you cannot use the unstructured data for machine learning. So the encoding is that process. So after encoding, unstructured data becomes somewhat structured, and then classification problem can involve both types. So it's kind of orthogonal space. All right, so I guess nobody.
So are you asking us to tell you what some classifiers are for supervised learning, like the k-nearest neighbor?
Yeah, that's specific examples. But I was asking about the nature of classification task. What is k-nearest neighbor doing? What is decision tree doing? Things like that. It's trying to, to learn how to tell which one is this, what outcome is this example based on the information that learned, right? To tell high income earner from low income earner, to tell apple from pear, things like that, from pictures. So that's a classification task, or we say problems. It's a type of supervised learning, basically, right? All right, so let's try the last one. So the last week I talked about strong and weak AI. Can you give 2 examples of weak AI? Alexa, Siri, wow. I don't know.
I was first.
I'm pretty sure it come from that side.
Yeah, it's Jordan.
Jordan. All right, great. Dessert. All right, there's gonna be more to come next week, so you know. Okay, great. That was fun. So I have half an hour. So let me go to the. Oh, so to quickly detect problems, mostly. I'm going to talk about both numeric as well as categorical, which is more text data, but this is more structured. Categorical variable is more structured. It's not like free text. So I'm going to talk about both scenarios. If it's a numeric, it's mostly numbers, right? So with numbers, some of the variables are highly, I guess, vulnerable to user input errors. When user input errors, that might, positive numbers may be negative, or values may be outside the normal boundary for this variable. Let's say income should be between maybe 100 to, I guess, for normal population, it should be between a couple hundred to maybe several million, something like that. But if you have a person with income into the billions, you can probably be sure, depending on the problem, you can be sure that that's a user entry error. So how do you quickly detect it without having to manually look? Or you don't have much of a computer intelligence to do that, but you have a middle ground. You can use visualization to quickly spot those errors. I'm going to talk about a few examples. So let's see. So this chart for the first one, for the second one, for numeric variables, it's hard to draw a straight line. Okay, because it's twisted. So for numeric variables, let's say income. Tell me what. This is not bonus question, but tell me what kind of graph is this? This is 1 million. I hear bar graph and histogram. One of this is more accurate. Histogram for interval variables, although it is bars, but these are, these bars stand for a range instead of a specific value. So this is between 1 to 1K, 2K, something like that. And the height is what we usually frequency or count, number of people count, or frequency, number of people who fall in that category or in that range. So this is a shortcut to kind of detect values that may be an input error. If the normal boundary of this variable is between 0 and 1 million, if you have a billion point here, you can quickly detect it. But the problem is when you have a large data set and you have most values are in this range, and there's one or two values in a supersized value. This is your graph is going to look like this, things like that, and all the values will be concentrated in the small region and a large gap, and then this is 1 million, but this is 1 billion. you know the scale, it's 1 to 1,000. It's not going to be, I mean, you certainly cannot present this graph to your boss because it doesn't look well. So you need to have some kind of a trick to improve it. So one trick that you can use is to transform the scale of the x-axis to use logarithm scale. The good side is that super large values after being log transformed is not built so super, but still you can fit that into the same graph without messing up with too much of the other values, but still you can see a gap between them. So a graph like this where you have almost all the values concentrated on here, but you have a value that's very big on scale. If you use log, this is going to be what it will look like. So if this is x, then you'll use log with base 10 just because it works better with graph. Then this is x and this is log x. If x is 1, then the converted value will be 0, right? So this is a converted value. Log 10 of 1 is 0, right? This is going to refresh your memory about logarithm. If it's 10, if x is 10, log 10 of 10 is 1. Yeah. So this scale is going to be on the scale of the converted value. So so that's 1, and that's 0, and this is 1. So that corresponds to that. And when you have a value of 100, it's going to be 2. So original x is 1, x is 10. So it quickly get to the very large value. Then what would be a million? What's log 10 of a million? 6 zeros. It's 6. So, you know, I'll just skip a few because I don't have space. Here, let's say this is 6 and x is 1 million. So most of the data will be concentrated here. And then you have 1b. And what's the value of 1b after being transformed? Billion, yeah. 9 zeros. So it's only 3 units to the right. So it's not so far. It's not gonna, you know, collapse the graph, but you can still see the gap clearly, and you know, the graph will be prettier. Also, there's another problem. If there's only one user entry error, this bar is going to be almost unnoticeable. When, let's say, if your data set has thousands of records, these bars will have a height that is typically in the 50 or 60. And so 50 compared to 1, the height, you can also miss that in this graph. So what can you do? You can convert the scale of the y to, to make it nicer. So that way, convert both scales, and it's a very good tool. You can choose to convert the scales very quickly with just to specify one attribute in Python. It's very easy. We're not going to do it in the course. Conceptually, I'm just talking about this. But if you're interested, we can talk. So you can do that by using pandas. If you have a pandas data frame, then you can use that. You can leverage a method to generate a histogram. And we also use Matplotlib as well as Seaborn. I'll show you, a few slides of the codes. And pandas is, data frame is pandas. This is panda. That's panda, but I guess. All right. So, but I object. That doesn't look like panda, because that looks like bear. And I'm from China. I'm insulted. That's not bear. Panda look like this. And you have this. Obviously, I'm not good at drawing, but so you have a giant head to start with, at least. But the iconic would be this. Things like that. And don't forget the ear. So oh yeah. And I can do this.
Nice.
And wait. So pandas. They are cute. And we use pandas a lot to deal with data. Summary statistics of the hold on. With the categorical variables, the best way to identify problems is just to print the frequencies of the labels. So let's say for gender, you print the frequency table. Males how many, females how many. If there's a error label, something unintended, you can quickly spot it. Right. So that's pretty easy. With pandas, we say this only works with series. So one of the column. Let's say if you have panda table, but you select a specific column, and then use the method value underscore counts, it will give you that frequency table. Okay. Data transformation. Well, means and standard deviations and symbols. I'll not talk too much about that. In Python, it has specific methods to get the mean, sum, standard deviations, or you can get all the summary statistics all together by doing describe, data frame.describe. So I'll skip that. You can download the class demo Jupyter notebook. It has quite a few useful commands. And we'll skip that exercise here. And the for classroom demo, and as well as for all the homework assistant videos, I use this data set. So in class, as well as in class, I'm not going to do too much coding here. I'll explain some of the codes, but you can watch the videos. And so in video tutorials, as well as in class materials, we will use one data set to demonstrate all the skills. For homework, you will use a different data set. So don't do exactly the same. You need to understand what explore the data set in the homework and understand the structure of that, as well as the variables in there. But the codes will be the same for the same purpose. This data set, which I downloaded from somewhere, I'm not going to tell you. It's a banking, finance kind of context. 1,000 rows. Over time, you'll deal with bigger data set. This one has 1,000, and trying to do fields quite a lot. It describes customers' behavior in terms of credit card record and payment, and the target variable is whether or not the customer defaulted in the 6 month. So you can take a look at the documentation for the data set. You can download everything from Blackboard. The first module. Is that first one? Maybe on the dataset page, right? A few comments about the scale of the variable. Different variables come in different scales. Like for this example, we have a credit limit. And this data set is in a country where the currency is, I guess, it's like Japan. Currency is to dollars 1 to 1,000, so it's very big, but it's not that much. So the scale is between 1 to million, let's say. But the other variable is year birth. The same thing with if you transform it into age. The range is probably 50 years or 60 years. So the range is different. And that comes in to play when it comes to how do you understand the variation and the correlation between that variable and the target. Let's say if the target of interest is payment amount, you want to predict how much the customer will pay in a particular month to pay back the debt, right? So you make a correlation here. These two graphs are scatter plot with a fitted regression line to describe the correlation, and the direction is opposite between the two cases, but it's understandable. I say this is the positive correlations, although it's slight positive, which means for those who have a larger credit limit, you can expect this customer to pay more because he has more debt, over time. So it's a positive tilted correlation line. With year birth, slightly negative, which means the more recent the customer is born, the less of a payment power a person has, which is understandable. That's a younger population has lower financial, capability. But you can notice that the slope is, other than that they're opposite, the slope is quite comparable. They're slightly tilted, weak correlation, right? But the question is, does that mean the amount of difference in terms of payment power or payment amount is different if you change the same amount of value across the two variables? Let's say, in other words, the question is, if you change credit limit by 1,000, or let's say not 1,000, let's say by 40. If you change credit limit by 40 based on its original scale, the payment amount is going to change for some amount. And on the other side, if you change year birth or age by 40, same 40, the payment amount is going to change for another amount. Is the two amount comparable? Both change by 40 in terms of credit limit and age. is the change in the payment amount comparable? No. Why? Why not?
Because when you change the, for example, in your example, if you change the year goes by 40, it is going to make a significant difference in the amount that is actually going to get paid. Versus if you change the credit limit by just 40. So the difference is going to be quite large.
Exactly. It's critical to understand this point. And I guess it's more intuitive to illustrate on the graph. If you think about changing age by 40, you are changing all the way from this point to that point. You are changing across a graph from minimum to maximum. Of course, it's going to lead to a more dramatic change. As versus if on credit limit, a change of 40 is barely moving. So don't take the same correlation to mean that the change will be translated similarly based on the original scale. However, we have a mechanism to deal with that scale differences is by standardizing the scale. And the graph actually put it into perspective. These graphs have already standardized the scale by pixels on the graph, right? So the width of the graph, whatever that is, maybe 50 pixels. This is let's see, if the width of the graph has a unit of 1, then changing the value by 0.5 of that scale is going to move halfway through the graph. And that translates to a different amount for the different variables, right? You move half of the graph on different variables, it's going to translate to different units in the original scale. But in the standardized scale, like in these graphs, this 0.5 is 0.5. It translates to the same change in the target variable. So this is the power of, or the advantage of using, standardized or normalized variables. And this is one of the routine tasks we have to do to standardize all the numerical variables before we plug them into the model. That's why. Of course, some of the models are not affected by that, but still, the interpretation will be affected. Some models are not affected in terms of learning information from data set because those models have a way to, I guess, extract information without paying attention to the scale. But some other models are drastically affected by the scale. And you want to limit the scale between very small numbers, between -2 to +2. And these include all the complex neural networks. So this is the importance about scales. And I'm talking about input variables only. The target variable does not really matter too much because we're not comparing target with target. We're comparing inputs with inputs. And so to do scaling, there are two ways. There's a z-score standardization, which will recenter the variable into have a mean of 0 and standard deviation of 1. Another way is we call min-max or range normalization, which will squeeze the range into a normalized region of between 0 and 1. That's the difference. It's hard to say one is better than the other. In most cases they should work equally well, but you probably have a preference, and you just stick with your preference. It's fine. In terms of the programming side, let's talk a little about that. But I need to switch the window. for virtual. How do I do that? I'm going to share a different window. It's not here. Well. Okay, great. Can you see the Jupyter Notebook right now?
Yes, we can see the notebook.
Okay, great. I'm going to enlarge it. So this is the slides demo 1. To start the almost time. To start the data science basics, these are the basic packages that we'll use. Pandas, NumPy. Pandas, we use more pandas and less NumPy, but occasionally we need that, such as recognizing missing values. And we need these are two plotting tools, and to set the styles of the tool, also control the random number generating mechanism. So this reads the data. I want to talk specifically about a few commands here. This is how you make that graph. This graph is the same in the slides. To make this graph, you need to deal with the labels. So here I specifically I specify the range should be up to 600,000. So I specified that. This square bracket with commas in between elements is called list. This one is a very common data object in Python. We use that a lot. And then we sometimes convert that into data frame. But this is the rudimentary form of that list notation. And a little trickier is the range function. Range function is Python native function. Range function is used to create a sequence of numbers by following some pattern. So for range, I cannot write anymore. I have to write on the board. So standard grammar of the range has 3 components. I use short. S means start. You have a starting value of a sequence. Think about a number sequence with equal gaps. 1, 3, 5 is odd number. Things like that. You have a start. But square bracket means it's optional. You can omit that. And you have an end, is you have to specify that. And you also have a optional step parameter. So with that 3 elements, you can specify a sophisticated number series. The simplest form would be to use range 5. It will generate a sequence with 5 numbers starting from 0. The start is omitted because they only specify one argument, which is the end. So the number sequence will always start from 0 by default. It will translate to a number sequence from 0 to 4. So you see the way it works is the sequence will always end right before the end parameter. This number will never appear in the sequence. Keep in mind of that. And that is because the default start value is 0, not 1. So best way to use this is to infer the number of elements in that number. If the number is 5, I have 5 numbers. That's the quickest way to remember the value of that number. And if there's no step specified, it will always end with number before that. That's 4. Going to slightly more complicated scenario is 2, 4. Okay, now I have 2 numbers. You cannot skip star but specify the 2. You have to, when you specify step, you have to specify star. So if you have 2 numbers, it must be start and end. Start from 2 and write the 4. There's 2, 3. And so now, in this case, the and, you cannot use the and to infer the number of numbers, number of elements in the sequence, but you should do a subtraction. Subtract 2 from 4, you have 2 elements in that sequence. So that's what happens when you have a star and end. And in this way, the step is omitted, and by default it's 1. That's why it increased by 1 for every step. And so now we're ready to go to the most complicated scenario. Range. Let's make more interesting. -2, 5, 2. Okay, think about it for a moment and try to write out the numbers and try to figure out some of the patterns. So I'm gonna write it down here. Yeah, sorry, I cannot show you the board completely, but I'll write something down here and give them some time to think about it. So what's the number sequence?
0, 2, 4.
That's right. And how do you calculate the number of elements by using these numbers? How do you know what to expect without writing it out? If it's a short sequence, sure, you can write it out. If it has 1,000 elements, you cannot do that. So how do you quickly get, the precise number of elements? So this is range. So I was talking about these actually. No. Talking about the codes behind these graphs. And I was talking about range, function. It has an optional start, has an end, and it has a optional step. And the example I was writing is, okay. So to get that, the number of elements, 2, 4, is to, if this is start, end, and step, you should do end minus start divided by step. And then take the ceiling of that if that's decimal. So let's try that. 5 minus 2 is 7 divided by 2 is 3.5. Take the ceiling, it's 4. You have 4 numbers. So that's the way. And also, the step can be negative. So in that way, it should, the number sequence should decrease instead of increase. But then in that case, you have to specify the start and end correctly. Otherwise, it will give you an error. if you try to go upward, but you specify a step backward, it will complain. It'll give you an error. So based on that, I made that labels and the range, so you can take a look at how the graph is made, and if you're interested in making graphs prettier or take better control of the graphs, then you can learn a few things if you're beginning to learn Python. I'm not going to test you how to do that. You can simply follow script to answer the questions, but if you want to know how to do it, like you want to be able to code from scratch, you can try to memorize or try to understand how it works. At least you don't have to memorize everything. Everything is open book, but when I change scenario, can you do it? That's the question. This is another big topic. I think after that we're almost done. A little matrix formation we can talk about next time, but converting categorical variables into flag variables is a big topic, because it's inevitable. You'll have to do that in most of the business problems. So if the variable is categorical, there are different scenarios. Yeah, here. So let's say K is the number of distinct labels. For gender, we typically have 2 or maybe 3. That's K. And there are other kinds of questions. There are other kinds of variables that only have 2 answers, like yes or no, right? Can you think of an example? Do you have credit card? Yes or no? Things like that. So if K equal 2, and if the, well, erasing is very difficult. And if the data is number, like 0 or 1, K equal 2 is what we call binary variable or dummy variable. And if the value takes 1 or 0, then it doesn't require transformation. You can include that variable already. No transformation. If K equal 2, but the value is text, like yes or no, male or female, or other values, then it needs transformation. In this case, it's easier. You only need 1 line of code. It's quite easier. Well, should I think probably maybe the demonstration, the class demo has it, and take a look. It's hard for me to change switch windows, but there's so this is a special case. Like, you can use 1 line of code to convert it to a dummy variable with 0 or 1 and add it back to the table. Everything can be done in 1 line of code. If you didn't find it in the demo codes, if you ask a question in the notebook, I'll answer the question. I'll do some demos over there. But if K is bigger than 2, and hopefully not too large, maybe 50 US states, 50, not too much bigger than that, then there's a universal method to do that. In pandas, we will use get dummies, and the slides, the demo codes has the codes. We use get dummies, and I think it's here. Not here. It will create one column for a unique label. So if, let's say, k equals 3, it will create 3 columns and record the values like these. Like these. If the value is, if the variable is marital status, you have married, single, you may have divorced, but let's say you only have 3. The other is the third category. If the value is others, we'll record it as others. Let's say if there's an others column, and the first value should have others as 1. All the other should be 0. So that's the way that flag variables will flag the unique label in case there are more than 2 labels. If the value is married, then the column for married is light up. It's, sometimes we call it 1 hot. So every time there's only one value lights up, and all the other values are 0, 1 hot. And other should be 0, 2. And then after all the conversion, we will get rid of 1 column to get rid of multicollinearity. Perfect collinearity. I have to exclude one of them. And typically we exclude the first label that are numerically ranked. So that's why in the codes you will see drop first. You only have to specify drop first is true. It will drop the first for you. So all of these is done in one line of code. And then you only have to merge the data set, the converted flag variable data set with the main data set to add it back. Questions?
Yeah. So using multi-correlated variables, what did that do exactly again? What was it? It changes like the true R squared. What's it do to our model?
So yeah, the issue is the model become unstable. The model assumes all the information that you supply are, or let's say the model assumes nothing in the model can perfectly predict the other. But let's say if you have a gender variable, so you have, male or female, you convert it to 2 columns, a male column and a female column. If the male column is 1, 100% the female column should be 0. If you include that in the model will try to leverage 2 columns at the same time. But it will face a challenge where these 2 variables seems to be equally useful, but I have a hard time excluding one of these. The model doesn't know how to do that, so we need to do that for them. That's basically the reason. We drop one of them. Like if you have k equal 2, and we retain only one of them, right? If it doesn't matter what the k is, you only drop 1. And does it matter which one you drop? Computationally, it matters little. It doesn't matter at all. But you probably, let's say, if there's one particular label that you care so much about, make sure you don't drop that one. Because when you interpret the results, sometimes some data will take that label. Let's say here, this example drops the other column, and the other column probably matters least here. So we retain married and single. If we see both 0 under married and single, we infer this case is other, right? So that's the effect of dropping the other. If you drop married, then the thing left is the 2 columns remaining is single and others. So then you probably make the, analyst, researcher wonder what the other column is, which is married, which is kind of important here. So, depends on the context. You want to retain columns that you want to retain labels that are interpretable or that are meaningful to the task. But computationally, it doesn't matter at all.
Is there a way when you're, is this using the get dummies or the?
Yeah.
Is there a way to tell it just drop one of them?
Yes. By default, does it do it? I'm not sure. But you can always explicitly say drop underscore first equal true. It will drop the first. What's the first? It will rank the labels alphabetically and drop the first. That's. I guess that's it. The only thing remaining is matrix. We'll talk about it next time. So let's call it a day. And if you have Python installation related problems, please talk to me and let me try to solve it for you. Otherwise, you can start doing homework 1, right? I'm going to spend maybe 10-15 minutes to talk about what's left from the last lecture, a few topics, and specifically I'll I'll highlight some codes. I'll explain them, and the explanation should be helpful if you are not as familiar with Python. And I'll also review a few backgrounds about statistics and say a few things about linear algebra, matrix formations. We will deal with that later on. And then we'll do some bonus questions. Yeah, not excited? We can skip that, of course. Should we skip that? No. So after those, we're going to talk about this chapter. It's about splitting samples and overfitting. Overfitting is such an important concept and phenomenon and concept, and the whole underlying mechanism for why that happens is such an important topic, and that that informs about effective ways that you should deal with that. One of the techniques is cross-validation or train test split. I'll talk about train test split, and we will use, it's a good practice to examine the quality of the test. The quality of the split into the two sets. And the tool to do that is to use hypothesis testing to do that. So that, that kind of summarizes everything I want to talk about. So let's dive in. The first thing, let's see. The first thing I want to talk about is some of the codes in making in transforming categorical variables into flag variables. And here is the code snippets that I include in the videos as well as in demo on how to do that. I'll make it larger. Students on team, do you see the Jupyter Notebook file?
Yes.
Yes.
Okay, great. So the part I'm focusing on is here. So let's say you have a categorical variable. Here it's marital status. Marital stat has 3 categories: married, single, and other. Right? And last time I talked about when you want to incorporate a categorical variable into as part of the as part of the input features to include in your models, you want to convert it to a format that machine learning algorithms can incorporate. Categorical variables are not in a state that is ready to be included because most likely it's either in text format, which needs encoding, or it's already encoded but in a format that may mislead the algorithm. For instance, marital status may be encoded with numbers. If married as 2, single as 1, and other as 0. So even though it's in number format, you can include it as one variable as with other variables like age. But does it mean that being married is twice as good as being single? Some may agree with that, but we cannot have universal agreement on that. This is arbitrary numbers that are, that are selected to stand for some label, but these label itself, you cannot compare them. So the best way is to use flag variables to flag different status, So because these are qualitatively not comparable, but they are different, when you have many levels, or we say levels or labels or classes, are talking about the same thing. These are different categories. We have to use a number of dummy variables or flag variables to flag the different categories, so that after transformation, the machine knows, this flag variable means this category is effective for this case. If that is informative, model will pick up consistently. The model can do a good job there. So the conversion process is quick. You use get dummies to create a data frame with all the flag variables, with all the columns that it's automatically created by the code, and then you make sure you drop the first, right? And then the later codes talk about how to do a few sanity checks and talk about how to merge with the main data set, right? You create an ID column by using the main data frame, and then based on the common ID values, you merge the two data sets so that the dummy variables, the flag variables, are added back to the main data frame. So all of those are good. And the codes I would like to highlight here, which is useful, is before you do the conversion, it's always a good practice to have an idea of what are those columns, what columns will be created, and what column will be dropped. Because one of the columns will be dropped. Which one is it? So a few codes here that comes in useful. Here, the first line calculates the number of categories in this column. The column is marital status. It's quoted to indicate the label of the column. It's including the square bracket, which is a sort of a select procedure to select, to slice a specific column of this data frame. The data frame is df default. So that's the way you slice one column from a data frame. That's one way of doing that. There are many ways to do the same thing. This is one way of selecting one column from the data frame, which is quite standard and it's efficient. After you do that, effectively the back end Python is what it does is it selects a series. Actually, a column in a data frame is series. It selects that series, and then you indicate that I will use a method of that series to do something. The method is nUnique parentheses. It's a function. It's a method of that data object. What it does is it calculates the number of unique categories of this entire column and gives me a number. So that's why it's n unique, number of unique. That's what it stands for. You have to spell it exactly to use that method. But the naming stands for number of unique categories. This column doesn't have to be categorical. The column can be numeric. The column can be, can have natural numbers. But be careful with using that. If it's a column with decimal numbers, you will have as many rows of data as unique values because it's decimal. So typically we don't use that on decimal on decimal columns. Only use it on categorical ones because that's what's it supposed to be used, right? So and so that's one thing. But the next one, closely observe the code. It's very similar. It also takes the same column, which is series, and use another method which is unique. It's not n unique, it's unique. Subtle differences you may not notice, but I point this out to you. It's different. That unique parenthesis takes all the unique labels or values from this column and return a list of unique values or labels. So the difference of the output between these two lines, the first one get a number. It can be 1 if all the values are the same. It can be 3 in the case of marital status. There are only 3 different categories, or it can be many depending on the column. But the output of the second line gives me a list of unique values of this column. In this case, it will be married, single, other. And it will be sorted originally as they appear first. If married appear first, married will appear first. That's why I use numpy.sort to sort the 3 labels so that it's numerically sorted. Why do I do that? I want to know which one comes first, alphabetically, so that I know that first alphabetically ordered category will be dropped later when I use the get dummies because it's dropped first. That it drops the first alphabetically ordered label. It's not by appearance, it's by alphabetical order. So keep that in mind. If you didn't notice the difference here, I tell you the difference of the 2 codes. And by knowing these 2, objects, then you can structure. You don't have to print out these exactly like that. This is so that I can show you a few tricks of formatting your printout so that they are elegant and clear. But you don't have to do that. It's obvious that n label is 3, and it's obvious that the labels are married, others, and single, and they are in alphabetical order. Married is the first, others the second, and single is the third. Any questions on this one, Lily? It should be.
In a video, you have to watch the video. I think we don't have it.
You don't have it? I'll make sure I upload it. It's either, no, I think it's in the folder. It's in, let's see, maybe module 1, data science background, module 1 folder. Scroll to the below, it should say codes used in slides demo, something like that. That's Jupyter Notebook. When you launch Jupyter Notebook, you see the exact same thing. I've converted to HTML. But that's the same content, right? You know how to open Jupyter Notebook file? Yeah, once you download that, you open it, you'll see all of these. Should be. Huh?
What is the name of this?
Oh, sorry, no, sorry.
No, it's not.
That's that one. I'm confused by myself. Yeah, this is in the video. This is in the video. When you look at the video, I talk about some of these. Yeah. I would say by the end of your doing the homework, you have all of these, right? But you know that these codes use a data set to demo, and the data sets are different from your homework data set. But you do have these data sets to download from Blackboard, right? When you go through the videos, you can follow the video and do the same. And by the end, you will have that Jupyter notebook. Okay, so that's one thing. And one more comment here. After I have done the conversion, I have the flag variables in flag Meridol. Flag Meridol, when I print the first 3 rows, I only have 2 columns instead of 3 because one of them has already been dropped. And the column that's dropped is the married flag variable. So married is not here. But by having 2 of these, you have all the information. When the values for the other 2, which is others and single, are both 0, that means the specific row has a marital status of married. That makes sense? That's how flag variables work. And then
If you wanted to know not drop the first.
When
Choose other to be dropped.
Oh yeah, that's just more cumbersome. The codes, you have to do it yourself. You have to specify not drop 1. When you have all 3, you decide which one to drop, and you make it happen by writing codes. Yeah.
Just
Yeah.
Doctor,
Rena?
just one question. Like, where can I find the Jupyter notebook for this one? It says like hands-on.
Yeah. We're just talking about that. So there isn't a specific Jupyter notebook for this one that you're seeing. These codes, but the same exact codes are demonstrated and explained in different videos for different purposes. For instance, this part is transforming categorical variable into flag variables. There should be a video about that. And in that video, I go through all of these codes and then run them in process. So what you can do is follow those videos and follow along and run the codes by replicating these. Afterwards, you will have these codes.
Okay.
That makes sense?
Yes.
Right?
Yeah, that makes sense.
Yeah, so I was talking about once you have the 2 dummy variables, that's a data frame. You want to merge, and it's better to have a ID column so that you can merge based on the ID. And because the rows are corresponding to each other, you have the original data frame, and you use get dummies to create the dummy columns. The rows of that dummy column data frame should correspond to the rows of the original data frame. So you can simply copy the ID column of the original data frame into the new data frame, and those IDs should the ID rows should match the records, right? The way to quickly add a column into a data frame is by referring to a column that doesn't even exist, and then assign a column that has the same number of rows. That will not give you any error. That will do the job. In the end, by this line, you'll have the new ID column in that flags Meridol new data frame. That's the quickest way to add a column as long as you understand the structure of the data frame. Right. So once you have that, you merge. This is sort of like a relational database merge, SQL merge code, but it's not following the SQL syntax. It's the merge syntax for data frame. So after that, I check the rows. It's good, and I just want to say here, it's a Python programming trick that is quite advanced. I don't require you to be able to, I guess, fully understand and replicate and use it in your own programming right away. But it's always an aspirational goal to play with it and understand how to use it. It comes in really handy. This is called list comprehension. This portion, list comprehension, what it does is it select those column labels that conform to some kind of condition so that you don't have to pick columns one by one. As long as you have a pattern that you recognize among the columns that you want to pick. By using this trick, you can pick them effectively without having to specify the columns one by one. For instance, let's say you have 100 columns, it's hard to list all of them, right? And among the 100 columns, the column labels, there are 3 columns in these 100 columns that start with, I guess, score 98, score 99, score 100, and all the other columns has other names, doesn't have score or doesn't start with score. What you can do is write a list comprehension syntax and select those columns that begin with score. Then you have 3 columns names. You don't have to even know what the number is after the score. So that's a purpose. That's one use case scenario. No pressure to fully understand it. For beginner, it's hard. This line of code can be broken down into 3 or 4 lines to illustrate the process of what's happening behind. And this syntax is, helping to make code more compact as well as readable for advanced coders. But for beginners, it's not something I would require right away. And that's it for the code. And so what I want to talk about is linear algebra. When we go into the add-line model, the logistic regression, and later neural networks, we will deal with matrix formation quite intensively. The reason is that it helps you understand the bigger picture instead of having to illustrate the formula on each each line of each row of the data. A matrix formation makes the notation more succinct and I guess simpler. And the difference is when you use a matrix formation, when you use a capital letter, Greek letter, that letter alone, that by one letter, it stands for all the I and J and K different dimensions of that object. So you save a lot of notations. And the good thing with that is Python codes. Python can take care of matrix calculation. So you can translate that the matrix formula into Python codes directly. So that's a good side of it. But that requires you to understand what's happening behind these matrix formation formula. So that's why in those chapters, in those lectures, I'll talk about the underlying process of these matrix calculation. What is it doing, and why does it do this? What the first step, the second step, third step, and once you go through that, you have a kind of understanding. Then you will be able to debug if there's a mistake with the process. So that's a go. But here, let's start from easy. Let's start from simple. Put on the slides here. So, and you don't have to pay attention to these. These is so that if you don't have a Jupyter Notebook installed correctly or not yet, you can use online cloud versions just to test these codes. Import a few libraries, and then we have two matrix. That's a formation, but let's correspond the codes and the structure of that with the actual matrix values. How do you quickly tell the number of dimensions from the way that the matrix values are defined? It's by looking at, it's always square brackets. Square brackets indicates arrays, which are number sequences. But you can have hierarchical structures. When you have double layers of square brackets, that means it's one more dimension. That makes sense? So what you want to do when you look at a complex array formation is to first look at to determine how many hierarchical levels are there. How do you do that? By observing how many levels of square bracket pairs are there. You have one, this is bottom level, the innermost level of square bracket. You have one component. You have parallel, another component. They are on the same level. They are separated by comma. And then out external to that, you have another layer, right, of brackets. So that is two levels. When you have two levels, that is two-dimensional data object. It's like a spreadsheet. It's a data frame, right? Let's say if you have another layer, and here you may have other values here, but it has to be, symmetric in terms of if there are two layers here, there should be two layers here. And then you have a third outer layer. In this case, it's three-dimensional, right? So here it's not three-dimensional. I'll remove these, but these are right. I'll remove that. Okay, so two-dimensional. And how to know how many rows are there and how many columns are there. If we think of it as a spreadsheet, we can do that. A matrix is like a spreadsheet, although it doesn't have to. But I guess a conventional representation or understanding of the structure of matrix is by rows and columns. And that comes in handy when we talk about machine learning, because we always, these are columns, these are rows. We always designate these rows to stand for I, which is the number of, there's a different examples, different training samples, right? So we have from 1 to I plus 1, and all the way to n. and n is what we say the sample size. And then we have j. Typically we use j. In this course I use j to indicate the columns. You have between 1, 2, j, and all the way to which letter do I use? To n. M. M is the total number of columns, and these refer to different features. Different columns, different features, different input variables, the same thing, right? So remember the convention here. So how do you know n and m in this case? The external, the outer dimension should be the rows. The inner dimension should be the columns. What is the outer dimension? When you ignore the contents inside the inner brackets and only count the number of blocks are in there, that is the upper dimension, that's outer dimension. The outer dimension is the number of rows. So you have 2 blocks here that tells you there are 2 rows. And how many columns are in each row? And now you can count the number of elements in each of the blocks, right? There are 3, so that's 2 by 3. Translate to 2 by 3. By swapping the dimensions a little bit, hey Angela, by swapping the dimensions, it becomes 3 by 2. We recognize 3 blocks, each has 2 elements, so that's 3 by 2. So, you know, practice that mentality and practice that in coding. That will be helpful down the road. Okay, so in terms of, so let me bring you back to your college years. Linear algebra. What else do you? Economics, maybe. What else? So we have A and B. We know the structure of A is 2 by 3, B is 3 by 2. In terms of multiplying matrix, you can do only one but not the other. In this case, can you multiply A by B or can you multiply B by A, and why? Can you multiply B by A? And why not? Why A by B?
A is cross 3 matrix and B is 3 cross 2 matrix. So the total number, so 3 has to match like M into N is equals to P into Q. So M and P should match in order to perform a matrix multiplication. Yeah, excellent. Right. When you multiply, let's see, let's use X and Y. They are both matrix. The dimension of X is N by M and multiplied by NY and MY. What we call the inner dimension of both matrices, they should match. In this case, if X is A, the M of X is the number of columns is 3. And if Y is B, the number of rows is 3. They match, and it's good. If you do the other way around, if you do B times A, B is 3 by 2.
A is 2 by 3, they also work. But they will produce a different shape of matrix. So that's interesting, right? What cannot work is A star B or B star A. And here, star is not multiplication of matrices. Star is element by element multiplication, which means both of the matrices have to have the exact, not exact same, but they have to, one has to contain the other, or they have to be exactly the same shape. All right, so that's interesting. These codes, if you execute them, they will calculate what is calculating. A star B is not going to work because if you try to, let's say, if A is 3, 4, 5, minus 1, 2, minus 5, you try to multiply, not multiply, star multiplication, 1, 2, 5, 6, 3, 4. It will try to multiply element by element. When you have tried the first two elements, the third element doesn't have anything to multiply with, so it will give you an error. That won't work. So that's why this will give you an error. And to do matrix multiplication, you have different ways. You can use NumPy function dot. Dot is dot multiplication. A and B, if you switch order, it will produce different outcome, right? So you cannot. It's not switchable. At symbol does the same thing. Or if A or B is data frame, it does have a method which is called dot. This is not NumPy dot, but this is the dot method of the data frame. You can use A dot B, which means A at B, same outcome. All right, that's all here for what's remaining from the last lecture. Any questions so far? Great. Okay, so let's have some bonus questions. They want to listen up. And same policy. I'll ask a question, and whoever screams first and get it will get the points. Okay. All right. So the first. Okay. The first question is not what I talked about, but it's more of a, work on it now. But it's not intensive calculation, it's more of a guess. So I guess let's see who's lucky. Here I have a distribution. This is to illustrate the point about skewed distribution and how the mean in a skewed distribution will misrepresent the middle of the numbers. It will go off what you would expect because it's skewed. Okay? And so the tail will skew will bias the mean in a way. So this is some background information, which hopefully you remember, but you don't have to know exactly. This is gamma distribution, one of the exponential distribution family member. The gamma distribution formula is quite complex. This is none of the business of this course, but just so that you know, It's the probability distribution function line of this variable by simulating all the numbers. Underneath you have, if you cannot see clearly, it's 0, 1, 2, 3, 4, 5, and so on. And on this line, it's the probability between 0 and 0.4. Okay, so that's the background information. So my question is, by saying your answer in 1-digit decimal point, you know, or you can say a natural number, that's fine. That assumes there's no decimal. You know, 1, 1.1, 1.2, things like that. By saying your number, your guess, let's see whoever gets the closest number to the mean of this distribution. Visually estimate the mean and give me a number.
1.2.
1.9.
Wow, I have 3 answers already.
1.4.
Megan?
Do we have a range to guess?
Unfortunately. If I give you a range, you'll for sure you'll get it. Megan says 1.2. Who said the second?
Oh, you said second number or?
The second number.
1.5.
1.4.
1.5.
1.8.
And only, you know, trust that you're honest. Who said the second number?
I did 1.3.
Alex?
Yeah, said 1.3.
1.3? 1.3? Is that your
Yes.
answer? And the third answer is Musa, or who said the third?
1.29. 1.4.
Okay, well, let me take 4 instead of 3 to be more fair. 1.4. One more. Andrew.
1.5.
Okay. I can see how you play the game.
1.6.
1.1. I'll say 1.
Let's take one more. Okay.
1.
Is Musa? Yeah. 6?
Yes.
Okay. So whoever is closer to the actual mean will get the point. It's not, I would say, you know, in this game I cannot be very fair because it's all luck, I think. So 1.2 is here. It's close to the peak. Peak is right at 0.95, something like that, close to 1. That's the peak. But you know the peak is not the mean. That's for sure. That's basic, right? And also, the mean is going to be off from median. Median would be the middle point. Since the majority of the points are here, the median will be very close to the peak, but will be to the right a little bit to reflect that there are more mass over here because of the tail. So, but the mass quickly decline exponentially, so it's not going to be off a little bit. Mean is going to be close to 1 or smaller than 1. Median might be slightly higher than 1. Mode is that peak. But mean is going to be dragged by these large numbers. So it will be, you know, quite some degree to the right of the mean or median. Not the mean, the median and the mode, right? So this is in the right direction, but could be this one, could be somewhere between.
1.5 and 1.6 might be.
Could be somewhere here. So let me finish the game. Mean of the number of people who use mu, which is actual underlying mean, the expectation of all the numbers that follow this distribution is 2.
Nice.
Well, let's give them a round of applause. I think if not at all, few would have guessed close to 2, because it's just it's a little bit too off. You know, it's out of intuition, but it's actually that's the power of the tail. It drags the mean on the peak by almost by 1, or by more than 1. That's the actual expectation of this number series. So, yeah, congrats. Or, you know, the trick to the game is I only have to be slightly larger than the next one. So, guess the direction and try to shoot for it just by a little bit. That's the game. All right. Okay. Next question. In terms of transforming categorical variables, just scream your answer, okay? If I have a categorical variable that has 8 different categories, how many flag variable columns? Isa, congratulations. Now you all know, great. So it's whatever the number minus 1, right? Great. Don't you like this game? No? All right, that's all I have for today.